Azure Service Fabric is one made by Azure. It's now open source, which is pretty cool. Amazon Cluster Service is a closed source orchestration engine, kind of a similar mechanism. Which is the best orchestration engine for you? Walk into your IT shop, say Kubernetes and Docker Swarm, and somebody is going to talk to you for an hour about why this is their favorite one and why that's the best one and why we should consider nothing else. And I completely agree. That is the correct choice for your organization. We have to take an opinion today, so I'm going to talk about Kubernetes. So Kubernetes, it hosts containers, either Docker containers, or are there really any other containers nowadays? Well, there are. Containers aren't new, but for the most part, we look at, so you have a Docker container and hand that to Kubernetes. So what is Docker? Docker is this ecosystem around container virtualization. Container virtualization is lightweight kernel virtualization. And so Docker is the suite of tools around that. Kubernetes starts with, so you have a Docker container. So let's dig in a little bit to Docker. The analogy that I like is, what's the difference between AJAX and XML HTTP request? Nothing? Well, yes and no. XML HTTP request powered Outlook Web Access in the 90s. AJAX powered Google Maps and Facebook and that app that you're going to write tomorrow. XML HTTP request was hard. AJAX made it easy for the rest of us. Containers existed in Linux long before Kubernetes or Docker came around. Docker made it easy. This suite of command line tools, this ecosystem, allows us to carefully package our content into containers and ship those as machines into production. I think as an industry, we're almost past this, but let's dig in just in case. In traditional virtualization, we have our operating system sitting on bare metal hardware. We'll install a hypervisor, perhaps this is Xen or VMware. Then we'll install various virtual machines. Into each virtual machine, we'll install the operating system. Then we'll install our libraries and dependencies, and ultimately our application. If I want a second virtual machine, I install a second operating system, a second set of dependencies, and ultimately my application. In Docker, we take a slightly different approach. We're virtualizing the kernel. So we'll have our server. We'll have our host OS. Maybe this is Ubuntu. Maybe this is Windows Server. We'll install the Docker hypervisor. We're virtualizing the operating system here. And then we'll install our containers. Straight off the bat, you can see that we get much denser hardware utilization because we don't have a copy of the operating system in each container. We only have our application and its dependencies. Only the differences between our application and this host operating system. Any questions so far on Docker? So we're virtualizing the operating system. Because we're virtualizing the operating system, the container needs to run on the same operating system as the host. So if I have Linux workloads, I need a Linux host. And if I have Windows Server workloads, I need to run those on a Windows Server host. What's missing? What? Userland. Interesting. I like that. What else is missing? What about GNOME and KDE? What about Red Hat and Ubuntu? Can I run an Ubuntu guest on a Red Hat host? Or can I run a Red Hat guest on an Ubuntu host? I can, because we're virtualizing the Linux kernel in this case. Well, what's cool is userland happens inside the container, so we'll come back to that one. But what else is missing here? Well, I don't have Windows Server. I have Windows Desktop. And I have a Mac. You telling me that I can't use Docker because I have a Mac? Well, what we do in development is this. In production, we definitely want to go this way. We definitely want to have the containers as dense as we possibly can. But in development and testing, we'll probably do this scenario. I have my Mac. It has Mac OS on it. I have a hypervisor. In the case of Mac, it's Xhive. In the case of Windows, it's Hyper-V. And then I'll have a virtual machine. And then I'll install the Docker hypervisor inside that virtual machine. And I'll install my containers inside that hypervisor. What's really cool is I install Docker for Windows or Docker for Mac. It installs this virtual machine for us, this Moby Linux VM. And so all of our Linux content runs great inside of the Moby Linux VM, inside of our Mac laptop or our Windows desktop. So ultimately, we can do some really cool things with Docker without the identical hardware, with this kind of virtual machine running our containers. Ephemeral, isomorphic, and deterministic. What's really cool is now that we can deploy hardware easily, we can do really interesting things like easily upgrade, easily scale. I just turn the knob up and I have more, which is really cool. I love this part. In containers, as a developer, I work inside the container. I orchestrate, I design my container. I can hang the drapes just so. I can decorate. I can set my config files here, and I can exactly match the machine that I want. And then I close the door on my container. And that container then, in operations land, we have standard cranes that pick them up from these hooks in the corner right here. And we can plug them into our infrastructure, and we plug in Ethernet, and we plug in power, and they just fire up. Ops treats this like a process. Developers treat this like a machine. Even better, Dev and Ops share the same tools. No longer is it that 10-page Word document that we're throwing over the fence to do interesting things. We have one set of tools between Dev and Ops. That is really cool. So the Docker ecosystem. With the Docker ecosystem, we'll start out with a Docker file, and it explains configuration as code. We will take that Docker file and build it into an image. We can share that image with Docker Hub. And what's really cool, we're sharing that binary image. We're not sharing the source code. We'll have source code that is metadata associated with that, so you can rebuild it if you really wanted to. But I don't need to recompile the kernel once I download it. I have an image that is perfect. We'll run that image on a Docker machine as a container. So an image is like the binary, and a container is like an instance of that binary. We can do that with one container here. Docker file builds to an image runs as a container. Or we can do this with many containers. I'll have a Docker compose file that will build many images or pull many images from Docker Hub, and then ultimately run many images, many containers together in concert. And that's kind of the Docker ecosystem. We went past that really quickly because we want to dig into Kubernetes. But any questions so far right there? What's really cool, that's where userland lives. That's a lot of fun. OK, so in Kubernetes mode, these still stay as Docker land. These are Kubernetes mode. We're replacing our runtime engine, and we're replacing the mechanisms that we use to orchestrate these containers together with the Kubernetes variants of these. So I still start out with a Docker file. I'm still going to build that into a Docker image. I'm still going to share that Docker image with Docker Hub, but all the runtime pieces will be in Kubernetes land. We didn't break your knowledge. You still have all of these things that you're used to, but we add to that these pieces that are Kubernetes specific. Any questions so far? Mm-hmm. We can use the, I didn't hear you very well.
DTR, Docker Trusted Registry.
Yes. Yes, you're right. The Docker registry part is still in the Docker ecosystem, so we can still use the Docker Trusted Registry together with Kubernetes content. Good call. Okay, so there's kind of three main components in Kubernetes land. There's the kubectl, the command line. There's the master nodes, the control plane. And then there's worker nodes. It used to be called master and minion. Apparently that's not great, so now it's the control plane and the worker nodes. And then the kubectl, the command line. Some people like to call it kubectl. I love this in the video that I heard it from. He said, I'm not sure I want to be that intimate with my code, so I call it kubectl. So the three pieces. Inevitably, when we start out with Kubernetes, we get handed some blog post that says this. And it gives us this really cool graph of which I go, and we're all going to sit here scratching our head going, what is this thing? Here's this thing. As a developer, I create some content, and using kubectl, I pass that off to the API server. The API server will save it in etcd. Etcd is that durable data storage, and it'll automatically scale it across all the nodes. The controller manager notices that some content has been changed in etcd by pulling against the API, and the controller manager will kick off the scheduler, who will then do certain things. What the scheduler is going to do is the scheduler is going to pick a node to run it on and tell the kubelet to go do that action. So the kubelet will probably run the Docker command line to go kick off a pod. The pod then will do the actual work. cAdvisor will notice the content happening in the pod and will send that ultimately back to etcd so that we can do some analytics on that. So our cAdvisor is doing that. As a user, we're coming in from the internet. We'll get routed using a load balancer to whatever node that we need to. And this kube proxy will pick the correct pod to send our traffic to. Clear as mud? That's probably the first and last time that you ever care about it at this scale. We want to think about it instead as, I've got my container, how do I get my container to run? But here's the punchline here. Kubernetes gets microservices. Because Kubernetes is microservices. We have all of these pieces that run as containers within Kubernetes, and we can swap those pieces out if we need to with third-party variants or other community pieces. I asked Kelsey Hightower, why is Kubernetes the orchestrator that's winning? And he said exactly that. It's the community. It's the ability for us to replace pieces of Kubernetes with unique pieces that can do really interesting things. So, installing Kubernetes. This is fun. Step one, don't. Just don't. What's really cool is that Kubernetes is big and complex enough that the people who administer it are probably not the people who use it. So as users of Kubernetes, our first step is to go find a cluster that's already running. If you're on the public cloud, you can go to AWS or Google Cloud or Azure, and you can get a Kubernetes as a service. AKS in Azure, EKS in Amazon, GKE in Google will give you a Kubernetes cluster straight away. If you're in the private cloud, probably your private cloud provider has this built in. Mesosphere, OpenStack, Cloud Foundry. And there's actually a cool link that has just tons more. Wait a minute. Isn't Mesosphere one of the orchestrators that we were looking at a bit ago? Yeah. Mesosphere launches Kubernetes clusters if you opt for it now, which is really cool. If I'm doing this locally, I have two great options. I can use Docker for Mac or Docker for Windows that will spin up that Linux virtual machine and allow me to do really interesting things. I just go into the settings and I check the box saying, yep, Kubernetes mode. Alternatively, I can use minikube, which is a single node cluster built by Google, and it does all of that as well. Docker has more magic, which is wonderful. It'll do more things for you, like automatically proxy in and out of the virtual machine really elegantly. Minikube does less magic, but also exposes more of the details. And so you can choose which path you would like to go in. Would you like to kind of dig into the pieces and pull it apart? Minikube may be a better fit. Or would you like to just kind of get up and running? Docker for Windows or Docker for Mac might be a better choice. So locally, we have these two great options. And if you're on another cloud, you can go to, I love this list, appscode.com, APUIO, Amazon, Azure, Giant Swarm, IBM, Kubernetes. There's, lots of people where you just say, give me a Kubernetes cluster, and they'll just turn it on. If your provider doesn't give you a turn it on type of Kubernetes experience, you may want to choose a different provider. So we've got Kubernetes going. If you really want to install Kubernetes yourself, it's totally fine, beyond the scope of this talk, but you want to Google for kubeadm or look at the Kubernetes setup docs. Yeah, I made it out to be really hard. It's not that bad, but it's involved. Any questions so far on Kubernetes? OK, Kubernetes elements. This is really cool. Let's dig into the meat of Kubernetes. We have lots of different types of things in Kubernetes. We have pods, deployments, services, ingress, stateful sets, cron jobs, secrets, lots of pieces that do really interesting things. We're just going to dig into these top three today: pods, deployments, and services. Pods will wrap a container and give you a single piece that launches all the things. Deployments then talk about how to launch many of them. And services ultimately talk about routing inbound traffic. We could think of a service not unlike a router. Ultimately, there are lots of things, and here's where the community can definitely help, because you can just grab some other community piece and swap it in for various infrastructure inside Kubernetes. So all of these are described in a YAML file. Yeah, technically you could do it in a JSON file, but nobody does. So we have a YAML file that has, for the most part, 4 sections. The API version and kind of gives us a namespace and a class name, type name, and a namespace. And then we'll have metadata, associated data about that thing, and ultimately the spec that details how to build that thing. So here's an example pod file. And let me zoom in a smidge. We can see that this pod file has an API version of v1 and a kind of pod. Pod has been around forever. We've got some metadata. In this case, it says it's an Nginx. That's just a name I happen to give it. And here in the labels, this is just key value pairs of things. So in this case, I just happen to make up a name of app and a label of Nginx. And you can include other things, your department name, the product version. In this case, for this example, I just chose to keep it really simple. Here in the specs section, we list the containers that are in this pod. And so in this case, we have an Nginx container. We pulled it from the Docker registry, Nginx version 1.7.9. And we'll forward port 80 into it. So here's our pod file. When we spin up this pod, it's going to go download this image from the Docker registry if it isn't already on the box. It'll launch that container inside this thing, and it'll accept traffic inbound on port 80. Now, nothing's sending traffic to it yet. It's ready to go. So pods are generally wrapped by deployments. And a deployment will very specifically give you the details around this pod about, for example, how many. So here in this template section, this is a pod file. So generally, we don't use pod files directly. You'll see that we have the spec, the containers, all of the content from our pod file. And then above this template, we'll have interesting things like the number of replicas. We could have details about how many, how we should do rolling updates, how many can be down at a particular time. We can constrain memory or other resources. And then we have similar things. I gave it some labels. I gave it a name of Nginx deployment. And this is in the app/v1 namespace, and it's a kind of deployment. I add this slide because as you pull this deck from robrich.org, and as you start experimenting with Kubernetes, in older versions of Kubernetes, deployments were actually in a different namespace. So this is great reference for you later. So we've got a deployment that will kick up many pods, and the pods will listen. Let's route traffic into them. So here's a service. And this service very specifically says, I am going to route traffic to port 80 on that container. We have other content, which was really interesting. This selector, let's dig into that in a little bit. And then we have kind of the same name and labels and things like that. So a service has that selector piece. Here's that selector. It said app nginx. How do I know where to route that traffic? Which pods will receive that traffic? Well, what the service does is go look for pods that have that matching label. So here in our pod definition, or in the template section of our deployment, we'll list the pods that accept traffic this way. So the service just says, hey, go find me all the pods, and let's go do all the stuff. Services can be one of three types. We have cluster IP. A superset of cluster IP is node port, and a superset of node port is load balancer. Cluster IP gives me one IP address on the cluster. So I go to the cluster's IP, I go to that port number, and that'll route me to all of the pods. It'll do a round robin across all the pods. Cluster IP, one IP per cluster. Node port is that superset, and so I have one IP per node. It's a publicly exposed node, but it's on a port in the 30,000s generally. And so probably I'll consider that private if I have a good firewall around my cluster. Cluster IP, a superset is node port, and then a superset of that is load balancer, where it'll actually spin up a cloud-specific load balancer. If you're on Azure, you'll get an Azure load balancer. If you're on Amazon, you will get an EC2 load balancer. And that's really cool. I can now tie into all of the things about routing traffic into my application. Now, load balancer sounds like a really appealing choice. You may want to look at Ingress instead, because this is one hardware load balancer per service. And so as you scale up the number of services, you may be paying for a lot of load balancers. So let's go dig into Kubernetes. Any questions so far before we launch a demo? So we start with, so I have a Docker container. So here's our Docker file. And this Docker file is pretty simple. From nginx Alpine, I'm going to use the nginx container, the Alpine version. This happens to be built on top of Alpine Linux, so it'll be a lot smaller. And then into the directory user share nginx HTML is the directory where I'll start to copy the content. This is also the directory that will start up as my container launches. And into there, I'm going to copy everything from my current directory into that destination directory. So there's a nice space right here. I'm going to copy everything from my current development directory into the directory inside that image. So I have this index.html file, and that's great. Let's come here to the command line. I'm using minikube, but I can still reach into that cluster using standard Docker commands. Docker build -t. Let's go into the right directory. Docker build dash. Really? Oh. No, let's get out of the source directory. Typing is hard. Windows is hard? Yeah. Path source not found. Oh. There we go. Docker build -t kube demo v1. So I just happen to call this container kube demo. I happen to give it a version label of v1. And you see that we're using the cache. I happened to build this previously. So it just said, hey, I noticed that I've already done that. Let's just build it. So I've got this Docker file, and now in the kube folder, I just happen to create a kube folder for our Kubernetes content. Here is that pod file. So I have a pod file that specifies, let's use kubedemo v1, and let's forward in port 80. I could choose to launch this. And now I've got a pod running. In as long as it took me to type that, I have my machine running. It's fired up. So now I want to go to minikube IP. Let's go to this IP address. I'll go to port 80, not port 5000, port 80. And I will see nothing. Ultimately, nothing is routing traffic into this pod. Well, we also want to use a deployment instead. So kubectl delete -f kube pod. And let's start up a deployment instead. Here's a deployment file. And so this deployment file, notice here's all of the pod details right here. We left off the API version and kind. And we also left off the name because we don't want to hard code it to a specific name. Rather, we want to let the deployment kind of make up random names for each pod. We want 2 copies of it. And so let's schedule this. kubectl apply -f kube deployment.yaml. If I hurry, nope, I didn't. We now have 2 copies of the web server running. That's great. Here's our deployment. We wanted to, we have to, and they've been up for 4 seconds. How fast does your VM boot? OK, so we have 2 containers running. It's doing really interesting things, but we don't have any traffic going to it yet. Let's pull up a service. Now, this service is of type node port. And the node port being a superset of a cluster IP, I have the port, the cluster IP port. I have the node port, which I haven't defined here. And I have the target port, where I want to route traffic into. I don't like defining port here because I don't care about the cluster IP port. But it's a required field in services, so here it is. But I want Kubernetes to auto-assign that port to me. So let's launch that. kubectl apply kube service.yaml. Ooh. That was gorgeous. I did, thank you. kubectl apply -f kube service.yaml. I now have this kube demo service that will route traffic from the node port it chose to assign me 32350 into all of the containers. I know that my cluster IP is this 192.168.184.137. So I'm going to come here now to that high port, 32350, and I see my app running. Score! That was cool. OK, so everything's running. We've got our service routing traffic into the pods. The deployment has identified which pods need to run. And we're ready to go. We have a change in requirements. Can you upgrade the site to the next version? Sure. So of course, I'm going to fire up my app. And I'm going to come in here to this index.html file. And I'm going to change a bunch of content. And the Docker file didn't change at all. Here's my Docker file. I just happen to have it in a different folder, so I didn't have to live code that change. And I'm going to say docker build -t kubedemo v2. And so I've built that second container, this new version of the container v2. I'm not going to change my service at all. We're not using the pod file, but I will change my deployment slightly. here I'm saying I would like to pull the kubedemo v2 image, and I would like to set another attribute, this version v2, into each pod. Those are the only two things that I changed in here. Oh, I guess I also changed the number of replicas to 5. That was cool. kubectl apply -f kube/deployment.yaml. kubectl get all, if I hurry, the new ones were already up by the time I started. The old ones were starting to get terminated. We spun up new ones, we drained all the traffic from the old ones, and then ultimately flipped over to using the new ones. And then by the time it took me to explain all of that, we have now 2 new pods running with the new content. Let me go back to my website, and I see v2. No downtime deployments. And this is what Kubernetes is famous for. Yep.
How did you switch the traffic?
How did I switch the traffic? That is a great question. How did I switch the traffic? What's really cool here is this selector says all of the pods that I want to route to are labeled with this app kubedemo. And so here in my deployment, I didn't change that app kubedemo label. I only changed this version v2 label. So when the service kicked up and said which pod should I route to, it noted that there were 2 pods that happened to have this app kubedemo label, and it routed the traffic to them. How did I change the traffic? I didn't. I didn't need to. Kubernetes did that for me. Mm-hmm.
What happens to the user who is still using the service from previous?
Good question. What happens to the user who's still connected to the old one? In this case, there weren't any, so it terminated it right away. But it will actually route traffic to the new ones, and it will start to drain the old ones. Once the old ones have no active requests in it, and it gives it a timeout as well, then it will start killing those old ones off. Same thing if one fails. If I terminate a pod, or I kill it, or just go into Task Manager and kill a pod, then it will notice that I don't have 2, and it will fire more back up. What are your questions about Kubernetes? Yep.
How do you handle device stuff?
How do I handle device stuff? What do you mean?
So in Docker, for instance, using more infrastructure type stuff,
Mm-hmm.
say web app, if you want access to devices, you can't really do that with Swarm for the most part.
Like serial devices and USB things and cameras
so
and
let's say a loop device, right? 'Cause that's a version type thing.
a what device?
A loop device?
A loop device?
Yeah.
Yeah. A networking thing?
No, so like if you want to mount a file system, right?
Yeah. Mounting file systems. It's beyond today's discussion, but the thing you want to look at is persistent volumes. And they are really cool. Part of the premise of Docker containers is that they are stateless. And in your case, you want a stateful container. You want a durable file system. And so that's where volumes are really helpful.
That's not quite
No?
what I'm referring to. I mean like, so if you want to touch anything in /dev, right?
Ah,
Can you do that with Kubernetes?
yeah. Because the Docker container believes it's a separate machine, I can write everywhere into /dev, into all of the places. I have my own machine. It's a fake sandboxed machine, so I'm not actually writing to the host /dev. But in my little container world, I have the whole machine and I can write anywhere. This sounds like a great question. Let's take this offline and dig into this a whole lot more. So a note about this thing. We have a dashboard. It's really deceptively cool. I've got lots of controls. I can dial things up and down. This is really dangerous because there's a button up here that says Create that allows me to create content. I can pick on any of the things that I've scheduled, and I can scale them up or down. I can make these quick configuration changes. But here's my question. If I make these changes here, Where's the master copy of the content? It's in source control in that YAML file. So what happens when I deploy it next time? I'm going to go overwrite all of your changes here. The other hard part about this is it's really easy to not secure this dashboard. Ask Tesla about how that went. So here's my guidance here. This UI is really interesting, but don't use it. Instead, grab the Kubernetes analytics and pipe them off to your Elk stack or to another platform and use that as a read-only data store over there. Yep.
Is this an alternate to AppD, or does it play along with AppD visualization, the kubectl UI?
Good call. How does this compare to like application virtualization? Containers are AppV.
App Dynamics?
Yeah, App Dynamics. Docker containers don't have UIs. They're really targeted for server workloads. And so if you're trying to do application virtualization, AppV, that's probably better using a different technology. I would like to see Docker move into UI-based stuff, but it's not there yet.
I'm sorry, not application virtualization, App Dynamics, where we track different statistics as to whether the server is going down or what's the error rate, analytics.
Yeah.
I see a similar dashboard here in kubectl UI. Are these complementary, or can they play hand in hand?
Yeah, so how do I get analytics out of this? That's wonderful. kubectl get all. I have all of the details about all my things. So I can say kubectl describe this guy, and it will show me not only all of the details about my thing, when did it start, what's its node and IP address, but it will also show me the events that happened on that. And so in the same way that I can get those analytics off the dashboard, I can get them off of the command line as well. Or I can just use the API directly. That also sounds like a fun conversation. Let's take that one out in the hall, because that'll be cool. Thanks for coming, everybody. This was a lot of fun.